Hello people of the internet, it is me Ronnie, and today I'm going to be teaching you guys how to make Flask apps the right way, the correct way, and the most scalable way possible. Now, most applications you've seen run in a certain way. It's called a factory pattern, and it's prescribed by the Flask people. The palettes documentations actually show that it's a good practice to use the factory pattern. But personally, I don't really like the factory pattern. I don't think it's object oriented properly. It's not very scalable. It's a single function. Functional programming. I'm not really a fan of functional programming. I think object oriented programming is way more advanced and scalable and professional. Allows for instantiation, abstraction, just a whole lot more that you could do with a single piece of bit of code. A lot more use cases. I think one function controlling a whole application isn't really the smartest move to make. If you're making a nice little to-do app, there's nothing better. But for those that want to build companies, they want to get serious, build e-commerce, build platforms, I think this method will suit you the best. So let's get started. Okay, so let's actually go ahead and try to implement this superior pattern. So we all know how the factory pattern works. If you don't know, I do have a video out currently teaching you how to make the factory pattern. It's also the prescribed method for creating Flask patterns applications in the palettes documents for Flask. So it's not something new. It's very commonly used, taught on how to make Flask applications. So we're not gonna really get into that. But let's go ahead and implement the superior pattern. So we're gonna have a main file, main.py, and we're gonna import app from app, because that's the name of our module. And we're gonna have a good old if name equals main, and we're gonna say app.run. Nothing new. We're just gonna make sure that it's hosted on localhost and that the port is set to, I actually wrote what it is. It's set to 5,000, just to keep things compatible the way I'm set up right now. We're gonna make a folder called app, and inside of app, we're gonna make an init folder, init file, just to convert it into a module, so that we can actually make this sort of import possible. Now in here, this is where most of our Flask factory is actually gonna occur. It's gonna write from Flask import Flask, and we're gonna write a class. So instead of a function, we're gonna write a class, call it anything. I'm just gonna go with superior pattern, and we're actually gonna instantiate the Flask, not instantiate, we're gonna inherit the Flask class itself. Now we're gonna super init the Flask class, so that we can inherit every single attribute from the Flask class instance that we would usually get, so that we can internally single out all the scopes, so that everything is interconnected and there's no load order issues. And I will show you how to do that. Let's actually just implement the class. So what we're gonna need to do, we're gonna need to go ahead and write a init method. And there's a few surprising facts. So Flask class actually takes in a lot of keyword arguments, but they don't really need to be given a value. They just need to be given on their own. So when we super init, we need to provide those values. So those parameters are import name. We can just typecast that, type hint that. We also have a template folder. Can we just call that none? Well, we need to give it a value of none. And we have root path. Give that none type. I'm just gonna give it a none value. And we need to super init, so that we can actually inherit all of the values from the Flask application. So we're gonna have import name, template folder, and root path. Actually, I'm just gonna stick it like this. Now that that's done, we can go ahead and say our app is called, and we can instantiate and we can give it the good old import name. Nope, not in it, name. There we go. And that's essentially it. That's basically how this works. So with this pattern, you can go ahead and use self as the app instance in itself. So with that, you would normally have to go here and say app.app context and have to deal with import db, import guard, import login, all sorts of unnecessarily clutter. Now what you can do is simply use self.app context and work with it here. There we go. And that allows for a lot more cleaner code, a lot more less importing, a way more closed scope. So that okay, so actually let's go ahead and define some views so that we can actually see this application in action. The way this works is it's just going to go into the root directory of our application folder module. We're going to define a folder and we're going to say index. Okay, in here we can now have a views dot py models.py, and that's it. If we want to get a bit more extra, we can say main.py, and in here we can define our blueprint identity. So this will sort of be a handler for our index blueprint. It's sort of like a component at this point. So the way this works now is we go ahead and say index view, let's keep it Pythonic, equals blueprint. And here we can define, let's say, index view as a blueprint name. So then we can use it with the URL for. Give it name, because we want it to be bound to the app when we import it and register it. Template folder. We can now give it its own template folder because it's closed off from the other place. It's closed off on its own. Go to templates. So this folder will hold all the templates. Oops. And we can even give it a URL prefix, so that static content will have a way to actually reach this. Now let's actually import oops. And I think that's it. That's all we need in here. Now, down here, we're gonna say from dot views import all, from dot models import all, and bang, all we need to do is import this main. So from index.main, we can pull this, register the blueprint, and all of these would be picked up on their own. So in views, we can go ahead and say from dot main import index view, and now we can actually just go ahead and define some views. So index view dot route, and go ahead and say main. We can just say index def index return you're at the index. There we go. It's that simple. Now, if you want the DB in here, if you want the database to have access over here, we can simply just go ahead and say from extension globals dot database import db, and this wouldn't cause a load import error because our scope is closed in and dependent on the loading order. Now, the way this works is blueprints will be the bottommost import in the load order. So, import blueprints. Import blueprints. And we're going to go ahead and say def import blue. Now, you can call these anything you want. I just call them imports, prefix, because that's essentially what they're doing. You could call them handlers, blueprint handler, etc., etc. But personally, I think they're just importing them and applying them to the scope of our Superior Pan application. But you know, each to their own. Use what your imagination employs. And in here, we're gonna go ahead and say from. Now we're gonna use module-based imports. So from app dot index dot main, I'm gonna import the index view blueprint. And over here, we actually need to import. No, we don't actually, because with register blueprints, they're part of the app. They're bound to the app instance. Therefore, we can simply just say register blueprint. Bang. Too easy. Now, let's go ahead and actually run this. I'm going to remove this because I don't know if it's going to run. But if we come here and we go run. Uh-oh, we've got an error. So 3 slashes is memory. So we've not. So config. Okay, let's just apply it to memory. Oops. Okay, so ran into a bit of a hitch. Okay. So making a main file for the views doesn't really work out well. You do not want to abstract that much. It's a bit of waste of space and it creates clutter and also induces errors, but we'll move past that. So what I've actually done is took the index view and directly added it to the views, and then registered it using the index view. Through that, we've also so this is the pattern we'll employ every time we want to make a new view. So this folder, it can actually be placed, if desired, it can be placed inside of a component, so that we can say these are our components, so that this will look even cleaner. And we need to give it a init file. Nope, not there. And through this, we'll be able to say index app.components .index view. So this makes it even cleaner, and we should add another dot there so the relevant relative imports can actually access the database. And if we go ahead and run this now, we'll get the port running here. And let's actually see what happens when. Okay, so we're at the main index. Now, the error here is due to the fact that our index preview is this, but there's no routes actually bound to slash index. As you can see, debug mode is off. I don't know why that is. I think sometimes this can be a little buggy. That won't be dependent on you. That's Flask itself causing issues. But if you go /index, you're at the index. So this pattern, it's very scalable. You can, as you can see, you've got components here. It's very replicatable All you need to do is increase that. You've got a singular database connection. Now in here you can connect to PyMongo, MySQL, PostgreSQL, anything you want, anything that SQL Alchemy supports, or if you want to, use your own bindings, write your own ORM, etc., etc. Using this pattern, you can basically scale up to as many components as you want, play around with the internals of Flask, manipulate them, make them, you can even improve them, upgrade them how you want, play around with the settings, play around with the internals. Okay, so actually, let's go ahead and test out some SQL stuff with this pattern. So we're just gonna define a class for a to-do app, because obviously we're making a to-do app. It's the easiest way to test out a framework. We're gonna use the same import statement that we used in the views, because it's on the same level. And we're gonna go ahead and create a class. So an ORM class is actually gonna be a table. So a class is basically a table. It's a very Pythonic way if you actually understand it and see it in a certain perspective. But anyways, I'm gonna create a class called to-do, and we're gonna inherit db.model. So we're gonna create a model. Model is basically a table, but in a Pythonic method. This is very important. You need a dunder definition called table name, and we're simply gonna call it to-do table. Now the way you define fields is it's a variable ID. We're gonna call this db.column. So this is basically how you define a column in your table. This is gonna be an integer. So that's what we're gonna do. It's a database integer, and we're gonna need it's a primary key. And in order for us to define a primary key, all we need to do is say primary key equals true. Now, if we have more than one primary key, it is going to trigger an issue. So we do not want that. So this is the only primary key we're going to use. So we're going to need to have a name. So we're going to have name, same logic, and we're going to say db.string. Okay. There's going to be a string field. Normally you don't need to use the parentheses because it is inferred. But if you want to have that highlighting, you can use the parentheses. And this is going to be a nullable equals false. You can have nullables if you don't want this to be left empty. You don't want this to be left empty, you say nullable equals false. That's basically it. And to keep it simple, we're just going to have two fields. Just keep it bare minimum. And the way you actually create a record is through accessing the init method. And the way this works is we take in parameters, say name, because we want this name to be accessed from the outside so that this DB can actually apply some context to it. So we're just gonna say self.name equals name, and now this logic will be turned into an object that is ready to become a SQL record. So the way this would work is from here now, I'm gonna say from dot model import to do, and let's just see if this would run. Yep, everything's fine and dandy. And if we want this to do table to actually be in our database, we're gonna come down here to our init method. We're gonna come here, we're gonna say from app dot hit the Alt key. App.components.index.models. We're going to import our to-do table. And here we're going to say db.createAll. Now this is going to be dependent on, there's going to be an automated method. All we need to do is just import the table and it will automatically be created in the database. If we run this, no errors. Okay, so a little bit of oversight. So SQLite, so this was causing a bit of an error. But we move. So make sure that you have defined your database with 3 ticks and you don't use any OS magicry. Just let it run where it needs to run and it won't cause an issue. So if we run this, we see that an instance folder appears and inside of it is our database. Ta-da! And if we open this, we actually get to see our table. So we have our ID and we have our name. And if we view this in our DB browser, we need to reveal this because I don't know why VS Code has some security involvement. So come here, we see our database.sqlite, we put it in here, and we actually get to see that that table got converted into a SQLite table, and we can actually see the creation SQL. We can see that our integer is not null, and we need a varchar, which is a string, and that's not null as well. And then we have our primary key, bind it to it. Now, let's try to actually create some operations in our view. Let's go ahead and say index.route. And before we do this, let's go to templates and let's go ahead and say to-do.html. Now in here, I'm just going to go ahead and say in our body, we're going to make a form, and our method is going to be post. And we're going to close off the form. And we're going to say input equals input. I think we need the name. Name equals name. Type equals, I think it was string. Can't remember. And we're gonna say h, just so we can understand h1. Enter your to do. Now, right below this, I'm going to go ahead and say, we're going to loop over the data that we've just created. For the data in data fetch, and we're going to say end for, so this is clear. In here, I'm actually going to go ahead and say auto detect. Did it detect it? No. VS Code actually has a it actually has a template highlight for the that actually looks really bad. I don't remember it being this bad. Did we have Ginger 2? No difference. Okay, we move. In here, we're gonna say p -p. I'm gonna say data.name. Actually gonna go change it back. Oops. Nope. Not the time to be making these kind of changes, but anyway. That's basically what we're gonna need to use. Now, each folder can have its own templates. Each folder can have its own static content, which will be defined through this URL prefix. Through this URL prefix, each static content, we can just define, say, static folder. We can say static. Alongside, we can even say static URL path. Now, static URL folder and path is very important if you want component-based component-based static content. Because using URL prefix is not enough, you need this static URL prefix. Beforehand, you would only have URL prefix, but now they've been smart enough to say, you know what, we'll make a bit more discrepancy, and we'll have a static URL prefix. Now it's giving me an error because obviously there's no route. And we'll say to do. Just keep it simple. Def handle to do. And in here, we'll go ahead and say method equals post and get. I need to do a bit more imports. Response. We're gonna need a render template. We're gonna need request. Okay. In here, we're gonna have this good old if request.method equals post. We're gonna have this, otherwise return render template. I forgot, was it templates or template? Anyway, we can just do this because even with blueprints, it will automatically inject these templates folder into relative to the directory of this. So if request.method equals post, what we can do now is follow the simple path of, I don't know if you I'm going off the basis that we do not know how to work with ORM. So what we do is we say to do name equals request I think it was request.form name, and we say to do equals to do, and now we give it the name parameter, and this is now our record instance. What we do now is, now that we have our DB, what we can say is db.session.add, we can say to do, and then we can commit that now by saying db.commit. My bad, session. With this, our database will take the this instance, and SQL Alchemy would say add this to the database. Now let's go ahead and actually run this code, and oops, forgot that response wasn't actually part of the Flask ecosystem. Let's go to localhost, and we can go to /to-do, enter your to-do, anything, and we can see a successful post. And the fact that it's not showing up on this template is very simple. What we need to do here is we need to say to-dos equals db.query, and we give it the parameter of to-do dot get all. The bug is going crazy right now. To-dos equals, what did we give it? For data and data fetch. Data fetch equals to-dos. And if we go here, we refresh, query dot doesn't have get all. Oops, my mistake. So when you do db.query, that's when you want to anoint any conditions, but right now we're just gonna say to do.query.all. And if we reload our page, there we go. Very simple, very simple. That's basically it. Now, if we want authentication, all we need to do is go into extension globals, and make an extension called cookies.py. Now, cookies and JWTs, they're often compared with each other to see which one is better. I personally don't think there's much of a difference if you're using SSR, but if you are using SSR, I think cookies are easier to work with. That aside, I feel like it's way better to work with JWTs just because of the fact that they're more like server based instead of client controlled. Okay, so we won't really get into cookies that much because it's not very it's not relevant to us right now. But if we would want to implement the Flask login interface, what we could do is simply make a new file, an extension globals, and call it cookies.py, and we can say from Flask login import login manager, and apply the same logic that we applied for the database. We just create a login manager and instantiate the login manager class. And this is probably going to throw a hissy fit, so I'm going to close it prematurely. We go to init, and we make a new folder, new method, and we call it def import cookies. You can call it authentication or initialize authentication, anything. But because I use JWTs, I have associated login Flask login with cookies and Flask Praetorian with JWTs. So when I say import cookies, I mean Flask login. So the way cookies work is we're gonna say, first off, we're gonna have to import the login manager, and as we can see from here, we can apply this to the scope over here, and we can simply just go ahead and say from login manager, or we can say cookies import login manager. So once we have that limited to that scope, because we don't really need it exposed outside of the scope, we can go ahead and implement the user login method. So we're going to initialize it. Oops, got this off. And then this is the part people have a very hard time with. We're going to need to define login manager dot user loader. So this causes all sorts of plethora of circular imports. People do not know where to place this. This gets mixed up with the import for defining the database because you need the user table. We could simply just say from app dot components dot authentication import models. Now this can be applied over here as well. And import models. But in this case, we're going to need to say models import user. Okay. And over here, we're going to say def load user. This is all in the documents for the Flask login. I'm just showing you guys how you could implement this in the superior pattern without any circular import issues. All we need to do here is, because we have this import limited to this function's scope, because it is a function, it's not like factory pattern where it's just one function and everything is exposed to that singular scope. We have compartmentalized the scopes, and through this we have created an interconnected web of extension globals, which if you use a function, you can access that scope, but it would not intertwine with each other. Now you can see this import and this import, they are the same, but they cannot cause circular imports with each other because of this import, because of the way we do our context loop. It's pretty easy, I'm telling you guys. Just go query.get, and we say user ID. Pretty simple. We go here. Like I said, user our imports get our blueprints get imported last. Import cookies. Now, for the sake of this actually working out, let's actually go ahead and create a little mock-up of this, and let's actually see how this would work out. Okay, so I've created the module authentication. I've copied the pattern that we've employed over here for the index. We've got the models and the view and our templates folder, which holds our templates. Now, in order for authentication, we need to actually confirm that the user exists. In order to do that, we need some database operations. Now, what we need is very similar to what we've done over here. Matter of fact, it's very similar. That I'm going to go ahead and copy and paste some logic here. Now, instead of to do, we remember defining our user class as user. Table name is going to be changed to users table. Now we have ID, we have name, but we need some more additions to this. So we're going to say username is db.column. I'm going to say this is also going to be a db.string. And now we can say unique. So not unique equals true. Now, username has to be unique because that could be an email or that could be just a username. And then we also have password, which we're not very concerned with because because we're gonna hash the password. That's the industry standard. You need to hash the passwords. You cannot hold literal passwords. Hash identity comparisons is way more secure. So we're not gonna really concern ourselves with what the password is. We just need to let the user be able to provide it. It's gonna be the same. We're not gonna really have any fields aside from nullable equals false. Oops, forgot the equals. And in here, just gonna use some VS Code editing magic right here. I'm gonna go ahead and say that. Oops. I'm gonna save that. It's gonna format it for me. Take that out. Bang. Actually, while I'm here, what am I doing? And then, oops. Self dot. Whoa, calm down. I hate when that happens. Okay, now we've got that. We've instantiated that. So we know what's gonna happen now. We're gonna instantiate this. We're gonna get these variables from a form in our login or register, and it's simply gonna register into the database, but that's not very secure. So what we need to do now is we need to import from workzeg, workzug. I could never pronounce that. We go to security, and then we import check password hash, and generate password hash. The way this works now is this password is unique until it reaches this definition expression over here. Now, this definition expression over here can be overridden to generate password hash and password. There we go. Upon this, we're going to automate generate password hash. So we're actually not storing the password, we're just storing the password's hash so that next time we can compare the two hashes together. Now, with this, we're going to have some getters. They're not very pertinent. Just copy and paste them like everyone else does. There's not much to them. They're very get and chuck sort of thing. So don't really concern yourself with what they do. It's used for the library. What's causing the indent block here? Oops. That's an issue. Okay. Ignore this. This is just used for the cookies so that the library can actually work with this in more of an automated fashion. You just need to be able to provide this sort of thing. So over here it says check password, and what we're doing here is we're employing the check password hash. So this would actually return to check the if the user's password is correct by comparing the two passwords together and see if the hashes match up. Okay, so now that's done. If we try to run this, our tables should now include the users table. Here we go. Our ID, username. Whoops. Why didn't they? That's a bug. But yeah, anyway, you can see we employ the same logic, we get the same output. So that's strange. Why didn't it create the let's actually view this review. Oh, I wonder if we should just F5 this and see. Huh, that's strange. So why isn't the password field coming out? Okay, a bit of a weird hitch, but we move. So in order for we want these getters and setters to be able to actually be used in a valuable method. We need to actually instantiate. We need to inherit from Flask logins class schema, which is from Flask login import user mixin. Now this will be first inheritance, and our DB models will be secondary inheritance. Alongside, we need to add some attributes. Is authenticated, which is going to initialize them. Is active, and is anonymous. Oops. They only need to attach a daemon to this. But anyway, once we have this, we check in our database, our fields are created, and it's time to implement some logic. Now, our cookies are working because it's able to find the user class, it's able to assign a user ID, and it's going to automatically use the primary key to search if that user ID works. And this is basically, if the user even exists, then continue, otherwise throw a hissy fit. And on that note, let's try to implement some of the logic that we're going to use to actually apply the authentication or operations. So over here, I'm just going to copy and paste some code because we don't need to write it again. So instead of index view, we're going to say authentication view. And we're gonna say paste this and say auth. Through this, the users, and let's just make a dummy index for the auth. So we have the auth URL prefix. What we can do now is we can say authentication view dot route, and we can say /register def register, and we can say return fix it please. There we go. Don't know why I zoomed out. It's a bit hard to read. And let's try to. Whoa, what is that? Why is it giving us so much space? Decorator, no? Anyway, we go to our init method, our superior pattern, and we go to import our blueprints. We go from app. We've registered the authentication view blueprint, and let's go ahead and check it out. Oh, we already have this over here. So we're gonna go auth, not found. Then we go registration. Oops, misspelled it. Oh, it's a register, not registration. Do I need to define the method? Rookie mistake, rookie mistakes. Whoop whoop. Forgot the whole point of the decorator. If we refresh, bang, here at the registration page. Awesome. Now let's implement some authentication logic. So we have our request. Need to add some parameters, methods equal post and get. Whoops. Bang bang bang. Return render template. We're gonna say register.html, just so it can you know, upon get request, you always want to return a template so the person can actually interact with the logic. Don't know. Whoa, that's weird. Okay. So essentially, what we did with the to do routes, we're gonna do here as well. We're just gonna say add this to the database, and because of the unique fields, we just need to catch the exception and return that. So a lot of things are handled for us because of the way Flask is designed. We don't really need to catch a lot of stuff. We just need to handle the exceptions. So like before, we're gonna say if request.method equals post, we're gonna say username equals request.form username, and we're just gonna repeat this password and name, and use some. That's really annoying. That's really annoying. God damn it. We've gotten the data from the form, and now we're gonna need to check if the user actually exists, and we can do that by saying if user.query.filter by, and we're gonna give it some parameters. We're gonna say username equals username because we want that to be unique, right? And we're just gonna get the first value like this, and this expression will return something. And upon that condition, we need to say user already exists, please log in. And then we're gonna give them a button with a href auth slash login slash button. Otherwise, we continue and we say user. We're going to create a user instance. We're going to say user equals user. We're going to say username, password, and name. And then we're going to say db.session.add user, and then db.session.commit. And through that, we have successfully created a register route. And if we want, we can log in the user upon registration, but let's actually try to register the user, log in the user in a secure manner. So we're gonna use some code from here, and instead of register, we're gonna say login, and over here we're gonna say, so we're gonna get username, password, yada yada yada, and upon this, now this isn't gonna be a bad condition. We're going to use this condition, and we're gonna say if user.check password. So this condition, before we actually employ this condition, we need to create we need to make a instance if the user actually exists. So we're gonna say user equals user.query.filter by, like what we did before, and we're gonna actually use this to create a user instance, so that we've gotten that data, and that class will now, we will be able to give it some more permissions. So that instance, we're gonna say, we're gonna check the password. If that instance has the correct password, we're gonna give it the password that we got from the form, and then we're gonna say, oops, we're gonna simply say, I don't know if we've imported this yet, from Flask login import login user. There we go. We're gonna say login user. We're gonna give it the user instance, and we're gonna say remember equals true, because you know you don't want them to log in every single time they visit the site. So we're gonna actually store it in the cookies, and we're gonna just print out something to help us understand what's going on. We're gonna say user was authenticated correctly, and I'm not gonna do that. I'll log in. We're gonna have another folder. We're gonna have another file called user.html, and in this, we're now gonna say return actually, we don't need the user. That's what I was thinking. Why do we need that? Because they have string passes for HTML. Return redirect for authentication and then we can now employ the URL for, we actually need to import that first, URL for, and over here we're going to say URL for, this is a function, so we need to use the parentheses. We're going to get this view dot user. Oops, we actually didn't even import this, did we? So what we've done now is we've checked if the method is post. We've gotten the data from the form. We've checked if the user exists in the database. And now we've gotten that user that exists in the database. We've now checked if the password that they've entered on the site pertains to the password hash that exists in the database. And if it does, we log them in. And then we redirect them to their page. Now to implement their page, all we're going to do is we're going to use a current user from Flask login. So we're going to say current user. We're going to import that. I'm going to come down here and I'm just going to get this again. Just make things easier. Let's use me. Oh wait, we need a... Actually, the route doesn't really matter. And I'm going to say def me. That seems really weird. There we go, that's why. My intuition was correct. If now we're gonna say we're not gonna have any post requests. This is just gets. And we need to define that because we don't want the incorrect method. Request method. So we're gonna say if current user dot is authenticated, because that's the we've provided that we've initialized that variable in the models in our database. Is authenticated, is active, is anonymous. That's gonna be now employed over here. And we're gonna say return say s string current user dot username, and let's go ahead and say username. This won't really work out. I think we have to do it in a separate way, but we can say name current user dot name. There we go. Else we can say return you're not authenticated. Could we have... Okay, never mind. Yeah, responses don't produce a redirect. Otherwise, that would have been a very good way to say you're not authenticated and then redirect. But what we can do is we can say, we can get a little cheeky here, script login. And we can say, we can alert. We can say login. And then we can say prompt. Little JavaScript over here. Actually, we could just do this. There we go. And you could say you can actually use a confirm var k equals, and then if k, we could say window dot location. Is it s string? No, it's not. Window dot location equals slash auth slash login. But we're not going to really continue with this. It's just something you could do. You know what I mean? You know what I mean? We could just return redirect. This is a more Pythonic method. URL for authentication view dot login. Here we go. I just want to make sure I don't get any spellings wrong, because then that'll mess me up. But anyways, we run this. Our views should be working. If we now time to add the methods. So I've got that. This is over here, and you know what? Let's cheat a little bit. Let's just grab this template over here, and we can go register. Come here. You can say enter your creds. Input name, username, password, and name. There we go. I can even put this as password. Bang, bang, bang. We don't need this. And put this. Even just make this. You can take out the name, and there we go. It's that simple. If you come here, now we should reload. Enter your creds. Oh, should really add I think it was help. Title. What's the title? Yeah, there we go. Enter username. Is this it? No. What was it? Text? Hang on, let's just get this right. Never mind. Let's make this look a bit nice. Anywho, I guess we should just remember the username, password, name. There we go. Okay. Whoops. This should be here. String here. Don't know what I was thinking. There we go. Refresh this. Give a username and then our password. Let's call it string. And then we can give this the same as username. There we go. And if I press enter. Oh my god. Okay. We also need a submit button. Input type equals submit. There we go. Can't believe I forgot that. There we go. And now if we go back into our database, we go to the user table, and there we go. Our password is hashed, and it has created a nice little row for us. Now, if you want to go to the login page, and we type the same, we got the I'll just take this from here, get rid of this. There we go. Same dealio. We go. I'm gonna submit. Uh-oh. Unfortunately, you can't leave any false form fetches. I didn't notice that. Price you pay for copy and pasting, kids. Do not copy and paste like me. And let's not resend that. retype that. I seem to have, like, I cannot avoid making errors, but we move. Uh, for those wondering, I forgot about a little pesky. I forgot to actually call this method, and this would not initialize. So the loading manager would not be able to actually apply this logic, and therefore the login route didn't work. But anyways, let's go ahead and test this out. I'm going to enter my credentials. I'm going to submit to the login route. And there we have it. If we refresh, if we go to index, got the index, and we go back to me, it will sustain it. If we actually go here and check out Cookie Editor, it's a free extension. We go to session. We actually have our session variables, remember me token. We also have remember me tokens. And if a user wants to not have any of that anymore, we can say, we can actually make a logout route. And the way this works is, first off, we need to actually import that logout user. Whoops, def logout. And what we do here is now we can actually employ a very useful functionality of Flask. I keep saying Flask. Flask login is the fact that we can use the login required decorator. Yippee. What we can do here is we can say login required. And through this logout route would not actually be allowed to be pinged if you're not logged in. Here we can say if current user dot is authenticated, then we can say logout user current user. No, it does not take any so it uses this session to actually just log out any user. And we can simply say return redirect to URL 4. We can't leave this empty because a route must return a response, and it can't figure that out on its own. So we need to do that. And we're going to say views dot login. There we go. And let's rerun this. And because our cookies are sustained, if we refresh this and the server has restarted, our cookies will stay there. But now if we go to the logout, okay, so it seems that I was calling logout a bunch of times. So they've changed up some stuff. And we still have our cookies. Did they get deleted? They didn't. So if I go logout, oops. Okay, small mistake. We all make them. So I don't know what my head is. I even imported log out user, and I'm just doing a logout. Apparently that's an internal function for Flask what do you call it? Did you mean authenticate? Yeah. Login, my bad. There we go. And if we refresh this, we are logged out. There is no more cookies. But what we can do is we can log back in. And bang. Too easy. Now, through this, what we have seen is that we can create a very scalable, very versatile, and formidable, all the fun adjectives that we can use to describe the superior pattern. This can be used to implement all sorts of extensions, whatever you require, you need, you can use it. You can obviously SQLite isn't the best database to be suited for this use case, but it is what it is. You need to use something to get it up and running, and it's perfect for that. And if you don't want this, you can even define this here. But just note that you do need to instantiate it. And this is basically it. This is a superior pattern. You can use this to produce anything that you want. If we want, because it's based on the browser, these cookies here will be used to sustain authentication. Now, if we go to index and we go to from Flask login, import login required, we can now say login required here and login required here. Alongside, we can even add, we can upgrade the to-do table to make it a full app. We can say owner ID equals db.column. We can say db.integer. Alright. And self.owner ID equals owner. We can just grab this from the endpoint. Why does this keep opening? There we go. And pass this over here. Bada bing, bada boom. Okay. We go views. We have said login required. And over here, we've got to do name. And over here, we're going to pass in current user dot username dot ID. We can say dot ID. And current user, we can just import this from Flask login. Current user. Bang, bang, bang. Here we go. Let's test this out. Uh-oh. Okay. So if this happens, just delete your database and restart your app. Here we go. Auth.login. Whoops. Whereabouts was that? Let's fix this. Okay, small little detail that we missed over here. When we initialize our login manager, we can actually set a login view. And this works completely the same as URL4. In fact, I think it actually employs a URL4 to actually navigate to this endpoint. And we did not define that. And we are not logged in right now because we have restarted the server, so it's not in the session. So in order to reduce all discrepancies, we'll just remove that. We'll come back here, log in, and it's a bit of a bug. Can't believe I so we deleted our database, so therefore there's no user in there. And in order to avoid any more further issues, let's just create a user. We've got that. Let's log them in. There we go. And if we go to bang, there we go. It's all working fine and dandy. If we come here, we can see the owner ID is 1. I can't let's log out. You are not found. Oops, off/log out. And let's try it to register another user. Let's say 22. query number 2. And let's log them in. There we go. And if we go back to do, whoops. Okay, so it's just fetching everything. That kind of scared me. It's just fetching everything. So if we go into our templates over here, yeah, it's just fetching everything right now if you're in views. So we shouldn't query all. We should query this in a different fashion. So to do dot query dot filter by filter by, and we can say owner ID equals current user dot ID dot all. And through this, these should disappear. There we go. And now we have users can only see their own to-dos. There we go. Very helpful. Very useful. Come back here. Let me see. Owner ID has changed. Now, the same application would have taken so much more longer to debug, sort out the load order, do this and that. But all we've done is we've created functions, we've limited the scope alongside increasing the scope so that things that are constants, they can reach places where they couldn't before using the factory pattern, and initialization is way more formidable and not subject to scope errors, so that namespaces can actually be sustained and we can create more freely. So yeah, this has been the superior pattern. If you guys have any questions, please make sure to leave a comment down below, and I will make sure to get back to you as soon as possible. My Instagram and GitHub is also down there. Make sure to check out any free open source projects you would like to contribute to. And the source code for this code will be available on the Flask-Planet GitHub community. Make sure to check out some other repos we have. We have some great innovators there. They have a lot of cool stuff pertaining to Flask. May you be inspired by their creations. And yeah, happy hunting.
Won't come to your party, cause your friends are boring. I'll be in the city, walking around like a tourist. When you look at me and hate on me, I'm a mirror. If you look at me and don't like me, what does that say about you?